The next technique of integration that we are going to learn today is the trigonometric substitution. Now, a little bit of review from your class. We will actually examine three cases, whichever is applicable for a given integral. Now, remember that if your integral contains the form given by the first case, square root or any root of a squared minus u squared, where a is a positive number, then I call that you do the sign substitution. So you let u be equal to a sine theta. Now, whenever you deal with the case where you have some a squared plus u squared, where a is a positive number, you do the tangent substitution, where your u becomes or is substituted by, your integral is substituted by u is equal to a tan theta. Now, in the case 3, if you have in your integrand this form, square root or any root of u squared minus a squared, where a is greater than 0, then you do the second substitution, where your u is equal to a second theta. Now, in the given integral that we are going to solve today, you notice that it's just integral of dx all over the x squared, and then this is the form that we're going to study carefully. It's the square root of 4 minus x squared. However, if you look into this one, this 4 here that you're seeing can actually be written as 2 squared, right? So when this was written as 2 squared, this will become dx all over x squared square root of 2 squared minus x squared. It is very clear now that this follows from the case number 1, where your a in this case is now, of course, it's the number part, so your a is 2, and your u is given by x. Alright, so we're sure that we're going to utilize the first case. So according to the first case, or case 1, you let u be equal to a sine of theta. Now in this specific context, our u is x, our a is 2, and sine theta. So that's it. That's the very basic substitution that we're going to use. Now, this implies then that dx is simply 2, the derivative of sine is cosine, so 2 cosine theta d theta. Now, since we're basically doing trigonometric substitution, the integral that you're seeing above will be rewritten in terms of the integral or the substitution for this specific integral. So that means the top portion, the integral above, will be given by dx. Dx is simply 2 cosine theta d theta, and x squared, notice that your x is this one. I'm going to highlight x, 2 sine theta, and you have to square that one, so 2 sine theta, that's going to be squared, and then this one will be rewritten as that's 2 squared minus your x is 2 sine theta based from the u that we set there. Alright, so basically the integral above, this one, is now rewritten in its equivalent form using some trigonometric functions that you're seeing there. So what we're going to do now is a matter of simplification. So I'm going to simplify this by dealing with the denominator. So I'm just going to copy the denominator. Numerator, the denominator will become 2 squared sine squared theta. In our radicand, we have 2 squared minus 2 squared sine squared theta. Alright, so in that case, I will do further simplification. So this is 2 cosine theta d theta, and then let's have this as 4 sine squared theta. And then under the radicand, I will factor out 2 squared. So 2 squared will be factored out. So I am left with 1 minus sine squared theta. All right. So from there, I'm hoping you can remember. I will just try to write it here. Recall from your algebra that if you have, say, the nth root of a n multiplied by b, that can be simply written as a square root, nth root of b. Or simply, if you have nth root of a to the n, that will just be written as a. Now, that is applicable in this case because if you notice, it's not really written here, but we know that this is a square root, so you have 2 over there. And for the factor of 2 squared, that's going to come out of the radicand. So this will simplify into 2 cosine theta. I will just write the numerator. This one will be 4 sine squared theta. And then as I mentioned, this factor 2 here will come out. That's 2 square root of 1 minus sine squared theta. All right. Now, another thing is you have to recall from your trigonometric class that you have this identity, sine squared theta plus cosine squared theta, probably the most famous of the identities. So that means to say that sine squared of theta is simply 1 minus the cosine squared theta, right? Or sorry, it's not really helpful in this context. 1 minus sine squared theta is equal to cosine squared theta. Now notice that 1 minus sine squared theta is what we have under the radicand, and that is just equivalent to cosine squared theta. So I'm hoping you're seeing where this is going forward. So 2 cosine theta d theta, 4 sine squared theta times 2, and this one is just simply the square root of cosine squared theta. And recall again what we have here. I'm just going to put a pointer. This one, the nth root of a to the n is simply a, so that applies in your cosine because we have 2 over there. So what happens now is we have this integral of 2 cosine theta d theta. This is 4 sine squared theta times 2, and this will just become cosine theta. Right, and everything goes smoothly here because your 2 cancels out, your cosine theta cancels out, so your integral is reduced to a very nice form, a simpler form, which is just d theta all over. I'm going to take out 1/4 since that is just a constant out of the integral, so 1/4 sine squared theta. Now, if you recall, and I need you to recall this one, notice that 1 over sine of theta is simply cosecant of theta. That means to say that our integral can be re-expressed into its equivalent form, 1/4 the integral of cosecant squared cosecant squared theta d theta. Now, I need you to recall another basic form of integral involving trigonometric functions, the integral of cosecant squared x, say dx, is equal to the negative cotangent of x. So that's why I like this problem, because it simplifies. So what happens here is I have 1/4, and that this integral over here, which I am going to highlight, is simply equal to the negative cotangent of x. So basically I have 1/4 multiplied by negative cotangent of x. It's theta in this case. Negative cotangent of theta plus c. So that will be negative 1/4 cotangent of theta plus c. Now we are not done yet. because we're going to utilize our triangles in this case, recall that we actually set x be equal to 2 sine theta. Now, this implies that x over 2 is simply the sine of theta. I'm going to write it in red. Take note of the mnemonics that when we say sine is so that's opposite over the hypotenuse. And this will be relevant later. Now, in order to figure out what cotangent of theta is in this case, we're going to utilize some geometry or maybe trigonometry. Now, here, this is what we let in the first place. And I want you to look into, we're just going to do some angle theta over here. Now, you let x to be equal to sine theta. That means to say sine theta is x over 2. And recall, as I've said, sine is opposite over hypotenuse. If this is your angle theta, the opposite is this part over here. Now, that part is x. That part is x, the opposite. Now, the hypotenuse, of course, this is your 90 degrees. Opposite to that is your hypotenuse, so you got 2. And this side over here is actually this portion of your integral. I'm going to highlight that. This portion over here. So that will just be 4 minus x squared. You can check it yourself. You're just going to use the Pythagorean theorem for that. Now, why I'm doing this, it's because we're going to re-express cotangent theta here. So let's do another little bit of recap or recall from your class. Cotangent theta is what? I want you to recall that cotangent of theta is simply 1 over tangent of theta, right? And the mnemonics, if you can remember about tangent, is it's TOA, opposite over adjacent. This is telling me that cotangent can be expressed as the adjacent with respect to the angle all over opposite. Now, looking at the illustration, this will come very importantly here. With respect to angle theta, the adjacent side is this one. So you write 4 minus x squared all over the opposite. With respect to this angle theta, the opposite is this portion here. So you get all over x. Now this is telling me that the cotangent of theta is simply this one over here. That means that I can substitute that in my expression. So I have 1/4. The cotangent is just the square root of 4 minus x squared all over x plus c. So if you want to further rewrite this one, you get 1 over 4x multiplied by 4 minus x squared, or square root of 4 minus x squared plus c. So this is your integral now. I mean, this is the answer to your integral. So again, this is trigonometric substitution, particularly the one where we use the sine function.